So in the 80s is when drip and micro irrigation took off, right? The technology became available for us to have really pinpoint irrigation. Prior to that, we did border checks, right? This just flooding a rectangular section. We did furrows, which was, running a small strip of water, down like a swale, running it down. And it worked well.
This is Michael Ring. I'm a cattle and crop farmer from Northern Illinois, and you're listening to the Vance Crow Podcast.
Welcome back to the podcast. I'm glad you're here. Today, we talk with Kiel Taylor of Exeter Irrigation. Kiel got on my radar screen because of a little app called Clubhouse. And in there, people have discussions about all kinds of crazy things. And one that they are in is the agriculture discussion. So I've heard him talk about water and different ways that farmers need to band together to be able to explain the challenges to people living in the city. And after getting a little nudge from my friend Brian Mose, I invited Kiel on to come to talk to us about water issues in California. So you are in for a really interesting discussion, particularly if you're like me and you don't have any idea how a water well actually works, or how do you know how much water you're putting on plants, or what's the technology around this. This is a really interesting interview in the fact that this is such a central part of our lives, irrigating food, but it's something that so few of us know anything at all about. So I'm really glad Kiel came on. Well, we have had an explosion of two things lately. One, we've started to get a big influx of people doing the legacy interviews, the private interviews where you hire me to sit down with one of your loved ones to hear their family stories, to hear about their values. I recently interviewed a couple that's preparing to get married. Their wedding is just a couple weeks off, and they arranged to come meet with me individually and talk about their partner and how they met and what they wanted to remember and what they thought marriage would be like. And it's really been fun putting this together because at a year after their wedding, they're going to open it up like a time capsule and then hopefully have something that they can share with future children or grandchildren about the way that mom and dad felt before they got married. So I'm really excited to do that. The other thing is a bunch of people have been joining the Articulate Ventures Network lately. So this is a place where people that love the podcast, want to talk about issues, want to give me questions that I can ask the guests, and really just have a place where we are away from the tragedy of the commons of Facebook and Twitter, where what you're saying has to be filtered through, hey, anybody can read this and anything can be censored. In this place, we have great stimulating conversations. We hold a book club, a movie night. We have places where you can practice getting better at public speaking, and really a place where you can ask the group questions about things that you're interested in. I'm trying to clone some rose bushes in my yard, and I've already gotten a lot of good feedback from people in the network. So if you're interested in meeting people that like this podcast just like you do, go to network.articulate.ventures to learn more. And if you're interested in those legacy interviews, just go to store.articulate.ventures. All right. Without further ado, let's go to my man, Kiel Taylor. Kiel Taylor, welcome to the podcast.
Thanks for having me, Vance.
So you come at the recommendation of one of my favorite people in the whole world, Brian Mose, who had me sit in on some of your Clubhouse talks where people get together on Clubhouse and anybody can show up and meet in your meeting room on the subject that you guys are talking about. And you happen to be in one about agriculture, and you're a water person. You do irrigation and stuff like that. And so when I was out in the world looking around for somebody that could talk about some of the crazy water stuff that's going on in California, Brian Mose suggested you and I chat, and I am delighted to have you on today, man.
Yeah, it's good to be here. It's Clubhouse has been a great avenue for us to have these discussions and bring people from multiple avenues of ag together and get on the same page and understand that we're all in this as one body, one unit, and that it's going to take all of us working together to get our voices heard and to make a healthy change in the world of ag, but also in water and just culturally and how our country views agriculture on the whole.
So water in California seems to be a very big deal right now. It seems as though the Orville Dam went from being overflowing to, absolutely crushing, maybe, total dam failure, to now not having enough water to run even the turbines that are on there. So just give us an overview for people that are not familiar with California agriculture. How much water do you need? How much water do you have? And what is going on there?
Yeah, so a number of years ago, Oroville spilled over. We had a spillway failure on the dam. Oroville is a very significant storage facility. It feeds into the State Water Project. We need that water. We need that water to supply water to farms in the Central Valley and the Sacramento Valley. But it's also really important for metropolitan use and urban use. So one of the big users of that is Metropolitan Water District or the Met of Los Angeles. They take about, out of the State Water Project, they take about half the water, about 2 million acre feet. And it's a really important component to the whole system here. California water system is extremely complicated. By no means is any one person an expert. There's people who are good at certain aspects of it. And so we move a lot of water in the state because majority of the water falls to the northern part of the state, north of the San Francisco Bay Delta. And so we have to get that water down to the southern part of the state for agricultural use, for urban use. And it's very difficult to do that when you have various, stone walls that are in place that prevent the movement of water. So yeah, Oroville is a major component. We've got Shasta. We've also got multiple, canals, line canals, California Aqueduct, Franklin Canal, that move water all over the state. And we also have major pumping plants all along the aqueduct because the aqueduct flows against gradient, flows north to south, takes a ton of water over the Tehachapi Mountains into Los Angeles Basin. All part of old, arrangements that were made back in the early 1900s when California was being developed.
So, for people that haven't spent very much time in California, you maybe have this concept that all of California is growing all the fruits and vegetables, but it's actually just in a few spots, right? Like it's outside of LA, it's outside of Sacramento, it's up in the northern parts. So talk about the different areas. Your company goes all up and down California. Do you work with all different types of farms that are out there?
Yeah, so my company, we've got 7 branches, and we cover Oregon, California, and Arizona. My branch focuses in the Central Valley. We're one of 3 branches in the Central Valley because it is very expansive. We have 1 branch in the northern part of the valley, 1 branch right in the middle, and my branch is down toward the southern end. And everything from blueberries and walnuts, 3-acre projects to several hundred acres, and it is a patchwork quilt of crop based off of multiple reasons, both water availability, soil type, and also climate. Climate plays a big part. You're on the valley floor, and there are nuanced differences that have to be taken into consideration, when you're picking what crop is going to go where. And so we have to be mindful of frost. We have to be mindful of degree days, right? The temperatures that allow the product, whatever that is, tree nuts or tree fruit, stone fruit, to develop, requires a certain amount of weather to make that happen. And so it's a very expansive, like I said, patchwork quilt that covers the San Joaquin Valley and the Sacramento Valley as well to the north. And California is about 100 million acres. And of that, about half of it is farmed, and about 9 million of that is irrigated. And so it's a very important part of not only our daily lives, but also just California economy, because the amount of jobs that exist, both because of ag, but also along with ag. So it's an important aspect of California agriculture, but also providing for the United States, providing food for the rest of the country and the world.
So it's funny to me because California agriculture seems to be so, instantiated, such a large institution that it seems surprising that anybody would still be putting in irrigation. I would imagine that all the wells that need to be drilled or all the reservoirs tapped into. Is my conception just off?
No, there's always work that needs to be done, right? Because there are markets that constantly shift. You see shifting because of the citrus industry. You see shifting within the walnut industry. Because, there's marketability, but the reality is, those trees don't last and don't produce forever, right? So some stone fruit, you might get 10 years out of it, but it's being rotated out because it has to be kept productive, right? Dare I say, it needs to be fruitful, right? So it's an important part of the necessary process. The reality is also that wells fail. The reality is that ground shifting happens. We're in a very seismic active area, and so wells will shift, and so you will get like a stenosis effect where a well will move, right? And so you don't have the ability to pull the pump out anymore, and so you have to abandon it because you can't pull the pump out of the ground in order to do the work on it. And so you say, nothing I can do. I have to drill a new hole because I can't get my old pump out to fix it, right? So there's all these things that come into play. And the reality is the equipment that we put in the ground doesn't last forever. So the pipe in the ground lasts a lot longer than the tubing that sits above ground. But it has to be replaced. The reality is that our water quality is very good in some areas. It's very poor in others. We can filter that out. That's what my company does. It's a component of what we do. It's getting good filtration in, but we can't get all of it out. It's not economical to pull all of the particulate, pull all of the material that's in the water, right, that's suspended out. So that moves into the system, and over time that creates problems. There's maintenance you can do to help stave off, major issues, but at the same time, we have to replace that equipment. And so the piping has to be redone underground, the tubing has to be replaced above ground, and that's just normal wear and tear. If the crop is no longer desirable, or they need to go out of rotation because they're changing because of old trees or non-productivity, or it's just not a wanted product anymore, then we have to come in and we have to redo. So you would think that at some point we would hit a point where the business would slow, and it hasn't been seen. This has been going on since the 1980s when drip and micro irrigation was adopted, and it's been a steady business since then.
So help me to conceptualize the way a well works, right? Like, because I can imagine, okay, you drill a well. Like when I was in Africa, they had bricked in wells where somewhere along the line they dug a hole, and then it went down, and eventually there's water. But if you're talking about California, how far are you drilling down? Is it when you hit water you stop, or do you keep going down and leave a pump down there? Do you have to hit the bottom in order to be able to set a pump down there? Just give me a map of what a well actually looks like from the inside.
So this is what I was saying earlier, is that the complexity of what is done in ag, right? There's a very wide breadth of work that has to be done, right? So we'll dive into the well aspect, but the reality is that is a very specific portion of what happens, right, to produce our food. So to answer your question, if you think of a well, think of it as, you're drilling a hole in a piece of wood, right? And that piece of wood is on a plate of metal. Well, when you hit that plate of metal, you have a decision to make. You either leave it there, because that's the bottom of your bathtub, or you drill through. So the main deciding factors, there's multiple, but the main deciding factors are, what's the water quality, how much water is available there, and what do you think is below it? Is it worth it to drill through that? So that would be like bedrock. Plate of steel would be like bedrock. So if you drill through and you just go to the plate, any water that's sitting on that bedrock in that bathtub, you'll be able to pull out of. You don't, when you hit the surface of water, you don't stop. You want to make sure you go to the bottom, because when the pump turns on, right, water can only move so fast through the pore space, right, that exists in our soil. So if you have a very, very, very fine soil, or you have very slow movement through that, right, you have to make sure that you have enough that when you pump the water out, it doesn't run for 30 minutes and then you're out, and you have to turn it off and wait for that water then to fill the well. So the brick well you talk about, that works, right? And there's even some seepage that will even move through the bricks in some of those wells. And that's desirable because that's how you replenish the well, right? If it's not coming from the bottom, it'll come from the sides. So, what we do is we put a steel casing in, right? And at a certain level, it's perforated. And so there's slots that are in the casing, and that holds back the material, right? But allows the water to pass through, and to fill that column, right? Fill the straw that's in the ground. And so what you want to do is you want to set the pump low enough that, and this is where you get into there's a touch to it. You want to put the bottom of your straw low enough that you have a constant supply of water that you need, but but not so low that you're paying additional costs to draw that water out of the ground, right? Because it takes energy to move that water. And when you're moving it up, that's where it costs the most. So the more you have to go up out of the ground, right, the less economical it becomes. But you also don't want to be moving that pump down every year, 6 months, 3 months, even 5 months. It's a very costly decision that you want to make sure is done right. So there's a trick there. You want to make sure you set that pump, right? The pump is the portion that's actually drawing the water out of the ground. You want to set that at the right level. What's that level? Depends on every situation, because there are so many variables that play in to just the aspect of picking your pump setting, right? And pump depth. That you have to partner with somebody who knows what they're doing and knows your area that you're working in.
And when you start drilling for a well, and I know there's different types of water management we can get into, but when you start drilling, are you sure there's going to be water when you start that drill up?
Yeah, so my company doesn't do any well development. We don't do any drilling. We partner with people because of the fact that we service a large area. And again, like I said, for us to know all of those areas it's not necessarily sound. What's really important is that we know who in the area we're working knows that area better than anybody else. So when they do that, there's different surveys, use different technology to see what's in the ground. But the funny thing is, you can pretty much drill a hole anywhere and you're going to find water, right? It's just a matter of what's the quality and how much of it is going to be there. And how expensive is it going to be to drill a hole, right? If you hit bedrock layer after bedrock layer after bedrock layer, right, you're drilling very slow when you hit bedrock. And so it gets very expensive. So there are guys who have been doing this for a number of years, 40, 50, 60 years, that can tell you that moving, 200 feet is going to be more productive. And they're usually right because they know what they're doing, because they've done it a long time and there's a lot of knowledge that they bring to the industry.
Man, I'm learning a ton here, and I know well drilling is not your thing, but all of this stuff is new to me. This is something, the closest I ever came to a well was somebody would say, hey, our water system is on a well, but I've never gone out there. I don't know anything at all about the pumps. And as you're saying, well, we don't do well development, then I'm kind of wondering, like, well, then what do? You just take it off of rivers and lakes? This is the only way that's the only three ways I can imagine getting water. I guess rain.
So where my company starts is at the flange out of the well, right? So somebody will come drill the well, somebody will come set a pump. We take it from there. So my company, we'll handle the power at the site, we'll handle the pump control, we'll handle the filtration, we'll handle the chemical injection, we handle the irrigation design out in the field. We do the once the water's out of the ground, that's where we take over. So we have to work with these pump companies, we have to work with the well companies, well drilling companies, so that way we can make sure everybody's on the same page and we get exactly what we need. Because if a well overproduces, that's inefficient. Because if I have nowhere for that water to go through my irrigation design, or if the plant doesn't need it, it's inefficient, right? And so there's constant synergy that happens in our industry between multiple layers, right, to make sure that the grower is getting exactly what they need. And it is so important that there is that communication, because this is how our industry operates. There's no reason to have extra input. There's no reason to have extra input costs if we don't need it, right? And the key is, for me, beneficial use of water. The water's there. We need to make sure that it's being used in a beneficial way and in a way that makes sense.
So let's talk about what you do when it comes off the pump. You're talking about, clearly not everything is spray, some of it's drip. I'd like to walk through how you come to the decision about how the irrigation is going to work.
Yeah, so we are service oriented, and in this day and age of everybody wants it now, it's very, very difficult to polished product that does exactly what the grower needs. So we've come up with some ways to make that happen without sacrificing quality. We have a great team, not only at the branch that I'm at, but also company-wide, that have been doing this a very long time. And, we work really hard to try and come up with a solution that is going to be beneficial for years to come, right? It's not about the bottom line. It's not about being the cheapest and the quickest to get it done. It's about having a solution that is going to make sure that when the grower flips that switch for the first time, up until the very last day he's producing on that field, right? And he's done, and he pulls those trees out or wherever he does, that system does what it was intended to do, which is grow food, right, and produce a crop that has the highest possible yields with the lowest possible input, right? That is, in a nutshell, if that was to be a mission statement, that's what it would be, right? Let's get our yields as high as possible with our inputs as low as possible. So the way we do that is efficiency and uniformity, right? So being an irrigation designer by trade, I guess, if you will, we have to look at two things. What does the plant need, and what is available for the plant? So there's many cases where we don't have enough water to irrigate the entire field all at once. So what we have to do is we have to make a judgment call, right? Do we put water on more slowly everywhere, or we put water on faster but in sections, right? What they would call blocks or sets. So we can play a numbers game by, kind of doing a juggle, right? And saying, okay, well, we have this decision to make. We typically don't want to put it on too slow because it takes too long, right? And we have labor that comes into mind, and there's other considerations that come in. But if we put it on too fast, it can become inefficient because it's disuniform, where you have puddling. If you've got heavier soil and you have rills and water's running all over the place, right? The water that was intended for that plant, is not staying at that plant. It's moving elsewhere. So, we have to look at soil type. We have to look at infiltration rates. We have to make all of this, the whole system work. And the whole system is not just the pipe and the facilities that we put in. The system also includes the plant, includes the soil, includes, the groundwater quality that's coming out. So, we have to look at filtration, right? Because as we're putting drip on, right, there's very small orifice, very small pathways that the water has to travel in order to make this whole efficiency and uniformity, game work. So with small holes becomes really important that we have really good filtration. So we handle that, right? We look at the whole picture, make sure that the spec that's being installed is going to work for the grower, right? But we also want to look at runtime, right? Because the longer you're running a pump, especially here in California, where we have something called time of use and peak rates, the longer you run a pump, the more expensive that operation can become. So little things happen where we've seen where, maybe a competitor's bid looks very similar, but their application rate's slower or lower. As a result, their runtime is higher. And so it's either you're going to pay for it up front, pay me now, pay me later. You're going to pay for it up front with a quality system, or you're going to pay for it for the life of the system, and that's operating costs.
So tell me about the challenges of irrigating if you're a farmer. You've got to make all these decisions. And then on top of that, do you have a water amount that you're allowed to use? Like how else does the factoring of water ownership work?
Yeah, so here in the state, there was some legislation passed in 2014, which was State Groundwater Management Act, otherwise known as SGMA, SGMA. And what SGMA said is that our groundwater is being depleted, right? We're pumping more groundwater out than what is inflow coming in to refill those aquifers. So the process started. There are GSAs that are Groundwater Sustainability Agencies that are, peppered throughout the state that cover most of the ground. And the GSAs are responsible for coming up with a plan, sustainability plan, otherwise known as a GSP, Groundwater Sustainability Plan, to say this is what we're going to do. This is how we're going to mitigate groundwater pumping and the overpumping that's been taking place. It's a very important legislation because we know we've been pumping groundwater, but we've been pumping groundwater because we can't get surface water. Right? California is in a drought. We're not short necessarily surface water, which is runoff, snowmelt. The issue we have is that we don't have the storage facilities to capture that and to be able to balance that around the state when needed in a case like this year that we're having right now in 2021. And so, when we're fighting that, it's difficult because, well, the growers need to grow food, so they need to get water out of the ground. So who regulates that? Well, the reality is agriculturalists are some of the earliest environmentalists, right? Because if you obliterate the soil, if you obliterate Mother Earth, there'll be nothing left. There'll be nothing left for you to use to produce. And so understanding that relationship has been something that agriculture has known for a long time. The problem is agriculture is seen as dirty and neglectful because of what it looks like on the surface. But no grower in their right mind is going to pump water more or longer or in excess because it's wasteful. Growers don't make a lot of money as it is. Margins are very low on almost every single crop. And so, who regulates that? Well, prior to 2014 in California, it was the grower, because they're not going to pay for more water than they need if they're not going to have any beneficial use of it. But 2014 put into effect to say, hey, we have ground subsidence, right? The ground is sinking in certain areas of the state. And so we need to mitigate this. We need to prevent this problem from continuing to get out of control. And so this was what they came up with. So who regulates it? Well, it's going to be State Water Resources Control Board and Department of Water Resources are now going to be working to make sure that everybody's in compliance, everybody's doing what they're supposed to be doing, and that inflows into groundwater are in excess or match what's been taken out. So there has to be a balance going forward. And I believe this starts in 2022.
So I really like this theory called the Gelman amnesia effect. And this is when you're reading the newspaper and you're like, oh, that's an interesting thing that they're talking about with the defense industry or some manufacturing thing you don't know anything about. But then you read a subject that you know a lot about and you're like, wait a second, that's not right. No, the way you're describing that's totally wrong. And then you flip the page, even though you've just had this experience where you're like, everything that you talked about in the subject that I know about was wrong. But now you go to the next page and you've completely forgotten that they didn't know anything on your subject and you assume that they do on these other subjects. So with that in mind, when you read the news about what's going on with water and the way that it's being portrayed, what do they get wrong that people wouldn't be able to detect because they're not in the game?
Yeah, Vance, welcome to my world, right? I mean, this is I don't know if anybody could get any more niche as far as agricultural irrigation design and construction, right? I mean, you couldn't drill down any further, right? I mean, we're at like the end of an industry here that the reality is there's a ton of people who think that they've installed sprinklers in their backyard or they've seen drip on a roadway median, or they've visited Hetch Hetchy in Yosemite, right? That they have some sort of connection to the water industry in California. And I've done a ton of reading on it, right? I mean, I'm a water nerd through and through. I enjoy reading on the subject. I enjoy researching the subject. And above all, I love debating and talking about it. And I would say that I might even only fully understand 5 or 10%, like actually like how everything of one aspect is connected, because it is so immense. So when somebody writes an article or they start to debate or they want to start discussing what's going on in California water and they act like an authority, it's really hard. It's really hard because it needs to be somebody who has, they did their bachelor's in engineering and they got a minor or they double majored with geology and they went on and got a law degree, right? And they were the top of their class in engineering and geology and really fully understand that. And maybe after they got their law degree, they went back and got a degree in hydrogeology or something, because the reality is there's the law aspect of it, right? You can talk about the law aspect all you want because I always talk about it being an onion. It's layers upon layers upon layers. And so if you're looking at the 10th layer, you have to say, how does that relate to the second layer? Because they're both true. They might not make sense. There might not be a direct connection, but if you're going for the next layer, you have to abide by everything that's stacked up there, right? And that aspect's way over my head. And I choose to not dive into that and touch that because of the complexity of it, right? And the sensitivity of the issue. But it's hard because, everybody says the number, ag uses 80% of the water in California. Ag does not use 80% of the water, right? Ag uses 80% of the portion of water that's not used for environmental. So in California, on average, right, dry years and wet years vary. On average, 50% of the water in California is used for environmental use. That's on average. So 50% is used for, salinity balancing in the Bay Delta. We don't need salinity, moving in to the Bay, right, and harming what that balance that's going on there. So we have to have so much outflow to keep that under control. 40% is used in ag, and the last 10%, again, on average, is used for urban areas. The bottom line is that 40% is growing food. If tomorrow people said there's no more gasoline, we'd figure out how to make it work, right? You'd hoof it, you'd figure out some way to get around. But if tomorrow somebody told you there's no more food, that's a very different story, right? There are people who can go and produce their own food. They can grow food in their backyard. They can grow food on land they have and share with people and whatnot. But the reality is, if all of a sudden California ag dried up and went away, we would be probably in the worst situation this country's ever been in, because the amount of food and produce that comes out of California through in the form of tree nuts and produce and vegetables and leafy greens and dairy, it's immense. And so we can't turn away from the issue that we have to be headstrong and head first into the California water issue, because we have to resolve this. It's not a matter of, we'll see what happens. We have to resolve this issue. And one of the things that gets frustrating is people fail to realize that LA took a large amount of water in the early 1900s, right? From Owens Valley, which is east of me. And then they went up a little further to Mono Lake, and that since has ended in a lawsuit that they no longer can take that water. But they have a number of wells all up along the Owens Valley that they use to pump water and siphon water back to LA. They're part of the Colorado River Aqueduct, right? And take a ton of water in an unnatural way into the LA basin. And then you have San Francisco, who Yosemite had already been formed, right? Needed a water supply. And so they go to Yosemite because that was the best location they could get a high quality water supply. O'Shaughnessy Dam gets built, Hetch Hetchy Reservoir forms behind it, and now they have what is the nation's cleanest water supply because it's coming from a national park, right? So national park water supply is, of course, going to be clean. And so, California is kind of slated as being environmentally friendly, but historically speaking, California is not environmentally friendly. We move a lot of water. We spend a lot of money and resources in the form of energy to pump water around the state, right? And so we need to come into a better balance, right? By no means suggesting that California, says that LA no more and San Francisco no more, because there's a lot of productivity and ingenuity that comes out of those areas. But we just need to have a better understanding, right? Californians need to respect that a necessary part of what we do is ag, because we need to grow food. And the rest of the country needs to respect that what California does and what agriculture does is produce food. And without that, nothing else matters, right? It doesn't matter, how fast of a plane we develop in Washington. It doesn't matter how cool of a device we develop in California. It doesn't matter what we do as far as vehicles in Michigan. If we can't eat, none of that matters, right? If we're not taking care of our own population, making sure everybody has nutritious food available to them, then none of that matters. And I think that's what ag gets frustrated is we get lambasted, and there's a minority. Agriculture accounts for single-digit people, right? 2%, about 2% of the population works in ag. And so we're an easy target because we're so small, right? But what's been nice is that, through avenues like this podcast, through Clubhouse, I know there's a number of people on Instagram and TikTok as well, the voice is getting out there, the message is getting out there. At the end of the day, we are producing food, and we enjoy doing that. And so
it's something interesting about producing food with water is that the water doesn't disappear, right? It just moves. And like this is something I've never really understood is when people are like, oh, ag is using so much water. Well, first of all, like let's just say with corn, for example, there's only a certain amount of moisture that is coming out of those fields in the form of corn that you're moving around. The rest of it then gets broken down in that stalk and all of the humidity that gets let off of all the leaves. So I've never really understood this. And I think maybe because the debate is either overly simplified or my understanding of how water works is overly simplified. It seems to me that it's not like the water is magically gone once it goes onto a plant.
That's correct, right? So water moves, it's two ways when we talk about from an irrigation standpoint. It's evapotranspiration rate, right? So it's how much water do we need to apply so that it's available for the plant. It's going to be taken up by the atmosphere, right? And it's going to remain within the plant. So water is a mechanism. It's a mechanism within the plant. And the movement happens both up and down depending on the time of day, right? So
wait, tell me more about that. What does that mean? I don't understand.
So the cells within, so if we look at soil moisture probes, like sensors in the ground, right? We actually see this diurnal cycle of the plant going up and down, right? As there's an exchange happening between the plant and the soil, right? So the water has to be there for the plant to be able to be fed, right? And there's this transpiration aspect to the plant, right? So it's not transportation, but it is the transportation mechanism. So it's transpiration, and most of the water put on, it moves into the plant, evaporates off. It goes into the atmosphere. One of the guys that has done a lot of research in this. There's a woman who's done research, and this guy has then taken this to the field and done this, and it's something like 5% remains within the plant of the water that's put on, right? Moves through the soil or remains in the soil, and is carried off by the atmosphere through evaporation, or remains in the end product. Right. So when we talk about, it's 13 gallons of water to grow an orange, right? Well, it's not 13 gallons of water concentrated in the orange, right? That's the full year cycle, right? Citrus is evergreen, so there's some extra care that has to be given there. That's the full cycle to get to that end product. But that doesn't mean that there's 13 gallons of water that are somehow in that orange, right? Or that 13 gallons of water are wasted and can no longer be, retained for use elsewhere. This is where the urban aspect comes in, because the agricultural aspect, right? Water moves through, it's part of the water cycle. That's it. In urban, we can lose it very easily to pollution, right? Because of street runoff, over fertilizing, municipal gardens or golf courses or even homes, right? So, all these things come into play. And once you get those chemicals in there, it's very difficult to mitigate that and to handle it. But you're right. Most of the water, it doesn't stay with the plant. It goes elsewhere, right? The water is just a mechanism to allow that plant to grow the food that we eat.
So when you said that irrigation really took off in the 80s because people started to adopt it, what do you think that changed about the water table and about the way that water is on the surface? Help me understand how, if you make such a big change, that impacts the earth itself.
Well, I think there's two things. So in the 80s is when drip and micro irrigation took off, right? The technology became available for us to have really pinpoint irrigation. Prior to that, we did border checks, right? This just flooding a rectangular section. We did furrows, which was, running a small strip of water, down like a swale, running it down. And it worked well. But the issue is if you had, really clay soils, you could put water on, but the water wouldn't go in. If you had very sandy soils, the water would fall right through at the head of the row, and it may not make it down to the end. And so with the advent of drip and micro irrigation, essentially you turn the pump on, and in that moment, there's a short period of system charging, but you then have water at every plant within the field, right? So the plant that's right here is getting the same amount of water and nutrients as the plant that's maybe half a mile away, or in a very large grow, several miles away, right? And so with this, we've seen a decrease in water consumption, right? And we've seen an increase in yield and productivity. And that figure is we've increased yield by 38%, but we've decreased our water usage by 14% in California. Largely has to do, right? It's a big number. Largely has to do with the advent and adoption of drip and micro irrigation. And so, it's become a key portion of how we grow so much food in this state. The problem is we don't have maybe the groundwater recharge that naturally happens through flooding and through various other methods. And so, how do we balance that? Well, the reality is we have to look at what Mother Nature already did, right? We have dams in place for reclamation so we don't flood cities, but we're also not flooding our farmland anymore like we used to naturally because of storms.
Oh, I didn't realize that. Amazing.
Most of the reservoirs built in the state of California were built for reclamation purposes, which is a fancy name for basically saying flood control. So dam it up, control the flood, release it when you need it, right? So what you do is you take say a 10-year storm, right, that might come through and decimate a community, it gets held back behind a dam, and you're able to mitigate that and also use it throughout the growing season to have the water available through the summer, right? It gets very hot here. We've been having 105 to 100 degree temperatures throughout the Central Valley the last couple of weeks. Plants need water, right? Temperatures go up, like we're talking about evaporation. The water is going to get pulled through the plant, and so you're going to get evaporation, and the transpiration is going to follow right behind it, right? And so we have to make sure that there's water available in the soil for the plants. So we build the dams to control the floods and give us a sustainable water supply back then, but that water is not allowed to come and flood the ground and then infiltrate. So what's happening right now is we're seeing a lot of recharge projects where they're taking ground that maybe is not ideal. Maybe it's got some sandier soils. And what they're doing is basically building a very shallow reservoir. They're going to fill that with water and let that water just percolate on its own down in to help recharge the groundwater. And so that's one of the big things we're seeing as a result of Sigma is the groundwater recharge aspect, that we have to be doing this. Whatever we take out, we need to be bringing back in, and we have to find that balance.
And who will be tasked with that? It'll be the individual farmer, or it's in some sort of water district? How does that, on what level of granularity do you have to re-add the water back in relative to what you took out?
Yeah, so that's where those GSAs come in. So the Groundwater Sustainability Agencies, which are made up of multiple, say, irrigation districts, right? So irrigation districts, they feed into the GSA. The GSA is part of the watershed or the basin that they're part of, and then there's multiple basins within the state of California. So the key is the GSAs need to do a good enough job so that way the state doesn't come in and then take over. State has already set assessment levels of what that cost is going to be, and most GSAs are saying they can do it for significantly less. So one GSA here locally, they're at about 10% of what the state's costs are going to be. So what they're doing is they're putting in a per acre assessment, right, to help fund these projects, and the GSAs are then buying land, bringing the water in, and working on the groundwater recharge on the GSA level. And for the most part, where I'm at, most of the GSAs are working together within each basin. There are some basins that it's become very contentious because of the geography in those areas. But I do believe that they will work it out, because the commonality there is we have to figure this out, right? And so there's a lot of growers who are working together trying to figure out, hey, how do we make this work? And that's who makes up the GSAs. It's irrigation districts, it's growers. I attend the meetings myself because it's really important that the voice gets heard across the board and that everybody's able to make sure that we're making good progress and we're making sure that we're replenishing our groundwater supply.
So these GSAs, are they autonomous? They're able to do what they need to do? They can set up agreements and trade with other GSAs, or how does that work?
Somewhat. So there's a board, there's an executive director, you have, executive personnel that help handle the day-to-day operations, but, there's multiple, committees that also feed into it. So, you have a technical advisory committee who's saying, okay, do we need to look at flow meters? Do we need to look at, putting in some wells, right, for testing? And so there's a ton of work that's going on, right? And it's all being done by people who are volunteering their time. They're sitting on boards, they're sitting on committees to make this work, and it's made up by growers. It's basically the constituency within that GSA are the people who are eligible to do that. There's county supervisors that sit on. There's engineers that are sitting on. So it's pretty incredible to see and to be a part of. But it is a very large undertaking.
On this podcast, we talk a lot about this concept we call fractal localism, which is, right, like the closer you are to the home, the more you share things, but the further that you get out, like the way that changes. So like inside of my house, I'm a communist, right? Everybody shares everything. Within my, extended family, I'm maybe a socialist. So there are some things that are mine, but for the most part, we pool our resources. And as you go further and further out, then you give up more control to the larger state, but only as you go further out, you want to give up less and less. So, for example, I want my local government to have more power than I do my state government, or I want my state government to have more power than my national government, because I have the ability to impact each one of these things the closer they are to my home. And I think that one of the big things that's gone on in our society is that people don't really feel like they have a place to go. And as I hear you saying, these water districts are staffed up or run by people that are volunteering their time. What on earth would be more important than being a part of the group of people that decides how to manage the water around you? Because it's a finite resource. It requires both you to think about the present right now and the future. It requires cooperation, because if if everybody's in there and hates each other and can't get along, then nothing's going to get done. You can't worry about the future or the present. The water districts, it's got to be a pretty profound thing, particularly during a time when we have so much animosity and so little participation in voluntary organizations.
Yeah, it's really important. You said what's more important, and right now, as far as ag's concerned, not much. It is so important that we get out there. We talk about groundwater recharge, and why is this so important? So if we take all the natural riparian, waterways, rivers, streams, we take all of the aqueducts that we've built, we take all the reservoirs that we've built, our groundwater has 10 times more holding capacity than all the stuff the state and the federal government has already done within California. So our groundwater is very important. It's very important that we recharge that. It's very important we put the water there and that we park it there, because once it's there, it doesn't evaporate, right? And so what's good about this is that the meetings that I've been to have been very wholesome. I love going to technical advisory committees, because the discussions that they're having about coming up with solutions and diving into this stuff, it's very good. And I sit next to customers of mine, growers, right, that I deal with. And I see growers that are, on the board and on the committees, people from the irrigation districts that I interface with when I'm working on a project for a grower. And so we all kind of join arms in a way. And it's been a great experience from the standpoint of, no, we are on a unified front. No, we are working together to make this happen. And so while SGMA is unsavory, what it has done, and it has brought to the limelight the fact that we are all in this as ag and water users. We're all in this together, right? And it's going, the other aspect of SGMA is the disadvantaged community aspect, where disadvantaged communities who haven't had access to good quality water supply or a resilient water supply, that is a component. And so there are communities here in Tulare County in California that have struggled with having a good water supply because of where they're located, because just the physical structure of where they're located and the groundwater is just poor. That's a component. And so working through, getting growers the water that they need, working through making sure we have some resiliency with our groundwater supply, but then also helping these disadvantaged communities. It's a great program. We need to do it. But what we need support on the state side to make sure that the surface water can get where it needs to go, right? And that we're having good, sound, practical solutions come into play at the right time.
So It seems to me I used to live out in California. I lived up in Mendocino for a while, but I got to spend some time in the Sacramento Valley. It seems to me that there are several states inside of the state of California, that you have kind of the left coast, then you have the farming ag community. What do you think over the long term? Can the city-urban desires for water and their impression of agriculture, can that be balanced out against the needs of ag, or do these two groups split apart and go their separate ways? How does this get managed over the long term?
Are you still recording, or is that's a really heavy question. So again, like I said earlier, I mean, no disrespect to San Francisco or Los Angeles, right? I mean, people who are there now weren't part of the decision that was made, 110 years ago. The reality is there's a disconnect. There's a huge disconnect between what most people are doing in urban centers and what people are doing in ag. And if we can bridge that gap, and we can kind of shed some light on the work that we do and the enjoyment that we get out of the dirty work, right? And the nasty work of, what it takes to produce dairy, what it takes to produce almonds, what it takes to grow citrus, right? If there can just be, let bygones be bygones, right? We would never want to live in an urban area. I have no desire to live in Los Angeles, right? And they would probably never want to live in an agricultural community, right? The reality is it takes all of us, right? It's the whole phrase, it takes a village, right? It takes all of us to make this whole thing work. And so let's be careful that we're not casting stones at one another. And let's just like ag is unifying, right? California needs to unify, right? And so we need leadership, and we need stewardship, and we need a sense of counsel that can come in and say, whoa, hang on a second here. Let's figure this out. Let's take these two aspects of California, right? Which is the highly urbanized centers and the agricultural portion of the state, right? And let's figure out how to bridge that gap, right? Does that you're talking about, basically your theory is basically states' rights, right? So, we need to allow the state to do what it needs to do, but it needs to be done without any kind of, like I said, casting stones, right? We need to respect that ag is a very important component to the state. There's a number of jobs that come out of ag. If ag dries up, we don't just lose the ag jobs, but we lose the jobs that are doing fabrication, doing manufacturing, doing development for ag related business. And so we got to figure out how to bridge that gap. And while I'm not big in politics, unfortunately, politics is a big part of what I do, or at least it has an effect on what I do. We've got to get leadership that especially in the state is less partisan, right? We've got to figure out a way to say, how do we connect these two halves? Respect that they are different, but they're necessary in order to make the whole state work, right? And so that's the thing that I've been saying in a lot of the discussions that I've had, and a lot of the meetings that I've been in, and the times that I've spoke to groups, is we have to figure out how to make the two halves come together and make a whole, right? Will California ever break off into separate governmental entities? Probably not. So we got to figure out how to fix it, right? Just like kids that fight, you're never going to not be brother and sister. So figure out how to get along, because you're always going to be brother and sister, right? So I think that's the big thing. If we can get the urban centers to appreciate what ag does, that's going to be huge. That's going to be a major component of helping just come to an understanding of who we are as California and the importance of California ag.
What do you suppose is the future of irrigation that most people are not imagining right now, but because you're in it, you see a future that's different than the way things are right now?
There's a lot of technology out there, right? There's a lot of ag technology that exists that can put a sensor down your well and say, where's your water level at? That can say how much flow is coming out of your well. It can say how much pressure your well is developing. Can even go and say, what is the actual motor doing, right? We can analyze the motor and say, you're having a problem and we need to fix it before it becomes a problem, right? So there's all these sensors, there's all this technology that's out there. And you look out in the field, We have valve control. We have soil moisture sensing. We have dendrometers, which is like think of it as like a measuring stick for fruit size or for plant trunk size. We have a ton of sensors available. And what's going to happen, and I'm all for people being gainfully employed, but as the labor situation becomes a bigger problem, more and more people will come out of the field. Less people will be working in the field. And what will happen is you'll have somebody who will be sitting at a computer, maybe in a pickup truck, maybe in an office, that'll be monitoring what's going on. And so they'll be able to go and address an issue with a pump, or address an issue with a motor, or address an issue with an irrigation system preemptively, right? There'll be proactive repairs and proactive maintenance taking place instead of being reactive, right? Blowing up a line or a well that's gone down, because they'll be able to sense this stuff ahead of time. I tell several growers, look, I can get you pinpoint accuracy on what you need to do, but you have to be able to do it. You have to have the time to be able to get it done. And there's so much red tape. There's so much reporting that they have to do already that a lot of them go, I just don't have time. But looking at soil moisture levels, looking at system performance, we can schedule out an irrigation to within less than an hour of what that field actually needs. And that's where we're headed. We're going to get to the point where instead of maybe you run for 36 hours this week, you run for 32, right? Doesn't sound like much, but that's about 12%. You cut that out. You cut that water out, right? It's not that the plant didn't need it, or not that it was an issue of putting it on, but it allows that water to be used somewhere else right now, right? So it's an immediate balancing act that you're taking place. And so I think we're going to see more and more of that. We're going to start honing in our irrigation schedules. We're going to start honing in our irrigation maintenance. We're going to be mindful of the main variables that we're using, or that we're looking at to develop an irrigation system. We'll just continue to hone in on that, and then we'll have better practices from the management side once that system's put into play.
One of the things that I've been watching very closely is Starlink. So I don't know how familiar you are with Elon Musk's internet project, but I think that this is going to have a huge impact on ag, and ag is barely talking about it, because what it's going to allow is way better than the satellite internet that a lot of farms had to deal with, or just the copper line that's running to their houses. Now, for anybody that doesn't know, you're going to get a satellite dish, and you're going to be able to point that to the sky, and it's going to be a radio signal from you to outer space. So that's as fast as it'll ever be able to go. But once it gets to outer space, now it travels. Instead of it traveling over fiber as pulses of light, it's going to travel from satellite to satellite using lasers. And lasers that travel through a vacuum, right, of space, is actually going to move faster than when it travels through the fiber optic cable. So suddenly you are going to start having people on farms that have faster upload speeds than people living in the city. And right now, much of the way that we conceptualize the internet is your download speed. How fast can I download this movie to watch where I'm getting both audio and video? Well, if you flip that around and you make it so that the upload speed is just as fast as the download speed, you can start doing things with data and switches and cameras that were never possible. So in that scenario, if upload speed becomes wildly bigger, can you think of other ways that people would be able to use that in terms of irrigation?
Yeah, I mean, having an answer right now, right? Having an answer right now, what's going on, and being able to make a decision right now, and then act upon it, right? You're not waiting for somebody to drive out there, not waiting for any kind of human to physically get where you need to be, right? And so, yeah, if we see a sensor and we see that we've got water down at 32, and we know that that's our target for water depth, at 32, shut it off, right? Make that decision, right? The amount of data that we move on farm is not that big right now. It really is not that big. And so there's also a technology, LoRa radios, LoRa, and the idea is that you put a radio or in every device, and they all talk to each other, and they just go. And so similar to Starlink, right, where everything is connected, and there are obviously some security issues and safety things that come into play. but where you have every flow meter, being remotely managed, and you have every, pressure sensor, and you have all these things that are online, will they ever replace a grower's shadow in the field? Never. You cannot replace the conventional wisdom of somebody who has been growing the product, whatever that might be. But it gives them one more tool to help them move just a little bit faster, help them react and make a decision just a little bit quicker, right? And like I gave the example of, if they can shut that water off, just, even if it's 3 or 4%, but if we make that move, that's enough to move the needle. If everybody makes a movement, or we on average make a movement of 3 to 4%, then we're moving in the right direction. And I think we're going to see that, right? Growers know there's room to improve, right? There is no question about it. It's a matter of how do we move that needle? How do we make those gains? And Starlink is going to be a huge part of that, right? And you're spot on with that, right? Moving data quickly is going to be crucial to making decisions in a timely manner.
So as we start to wrap up, Kyle, you've talked several times about how ag's trying to get the message out, and that you have to be able to reach the urban environments. Miriam Hoffman, one of the people in our network, asked the question, if you're living right now as a farmer in a state that doesn't have water rights issues or these kinds of fights because most of everything is just done through rainfall, what is it that those farmers should know about the challenges that you guys are going through with water rights and conflict over usage? And how could those farmers out there be helpful to farmers where you're at?
Yeah, great question, right? It's have the discussion, right? We're on Clubhouse every day. There's growers that are on Instagram. There's people like myself that's on Instagram. There's others that are on TikTok, Facebook. If you're on Facebook, use the tools that are out there, right, to communicate. This is one of the things that's great right now in the world we're living in, is that communication is instantaneous. But double check your facts, right? Just as communication is instantaneous, it's very easy to fact check anymore. A quick internet search will probably yield enough results to guide you in the right direction as to whether or not what you're seeing is true or not. The other one, and this probably goes above a farmer to farmer aspect, and the thing that I keep promoting is, when you're in the grocery store, look at the labeling, see what you're buying, right? The best thing you can do for California farmers right now is to buy California grown produce, because what you're doing is you're voting that you're telling your grocer, you're telling the buyer at the grocery store that this is what I want, and buy fruit that's in seasonality, right? Yeah, you can't buy kiwi fruit all year long because it's not grown all year long, right? Citrus is a little different because there's a lot of varieties that almost span the entire year. But if more and more people become hyper-focused on buying California grown or U.S. grown produce, right, what's going to happen is the demand for the import stuff is going to go away, and it's going to support California growers, and it's going to give them the income, it's going to give them the margins to continue to do what they do and do it better than they've ever done it before. And the reality is, when you look at the numbers of what California produces and how we produce it, whether it be grapes, strawberries, oranges, kiwi fruit, raspberries, the things that we produce in abundance here, we do it with very little water. And so while we struggle with water in California, the reality is we do a very good job of keeping our inputs down, keeping our chemical inputs down, having fair labor. And so by doing that, you make sure that the growers that are producing here continue to produce, continue to do what we do, and do it in a very safe, economical, and fair way.
And Kyle, if people wanted to learn more about your company or reach out to you about stuff that we talked about today, what would be the best way to do that?
That'd be on Instagram. I'm on Instagram. My name is spelled Kiel.Taylor. So Kyle.Taylor on Instagram. Best way to get a hold of me. I may not post a lot, but I'm on there regularly, and would love to hear from anybody that has questions or want to see what we do and learn more about California agriculture and California water.
Well, I'll definitely put that in the show notes. Kyle and I have mentioned a couple of times Clubhouse. And I can never remember the exact title. Is it just the Agriculture Discussion Group? Is that what it's called?
Ag Discussion. Yeah.
Ag Discussion. So if you've ever been curious, Clubhouse is like a podcast in the sense that it's just people talking and on their phones, and it coordinates so that people, it's not just a host and a guest. It's a long conversation. People pop in, they put their hands up and say, hey, I have something to say. It's moderated, so it's not just a complete free-for-all, but it does have a pace. And I got to hear Kyle on there enunciate his different points of view and talk about what they were working on. So I would recommend, if you're the type of person that likes agricultural discussions, it's 6 p.m. Tuesday through Friday, at least. I think maybe you guys even do Saturday and Sunday, but at Agriculture Discussion on the Clubhouse app. So if you're interested, go see Kyle over there. Kyle, thanks so much for coming on and talking about water in California.
Yeah, I could do it all day long. So I appreciate the time and appreciate having me on, Vance.